Hello, my name is Julia, and this is Space Daily News channel. In early 2017, astronomers reported the discovery of 7 rocky planets orbiting the ultra-cold red star TRAPPIST-1, 40 light-years from Earth in the constellation Aquarius. What turned out to be remarkable was that these planets have sizes and masses similar to the sizes and masses of such rocky planets in our solar system as Mercury, Venus, and Earth. And despite the fact that all of these planets orbit quite close to their star, they receive a fair amount of energy from their teeny star. For example, the exoplanet TRAPPIST-1b, which is the closest planet to its star, receives about 4 times as much energy as Earth from the Sun. It has a diameter close to that of Earth, and although TRAPPIST-1b is not in the habitable zone of its star, observations of it could provide important information about other similar exoplanets. So, astronomers decided to point James Webb's golden mirrors at this small rocky world. And for the first time using Webb's sensitive instruments, scientists were able to record the infrared radiation of such a small and cool exoplanet and measure its temperature. The result is an important step toward understanding whether planets orbiting small active stars such as TRAPPIST-1 could have the atmospheres needed to support life. None of the telescopes already in use by astronomers has sufficient sensitivity for such measurements. The measurement was made with the James Webb mid-infrared instrument, which recorded the thermal radiation of the planet. The measurements showed that the temperature of the illuminated side of the planet was about 500 Kelvin. Webb's team used a technique called secondary eclipse photometry, measuring the change in the system's brightness as the planet moved behind the star. Although TRAPPIST-1b is not hot enough to emit its own visible light, it does have an infrared glow. And although the star is more than 1000 times brighter than the planet, and the change in brightness is less than 0.1%, James Webb was able to measure it. The scientists also concluded that the planet most likely does not have an atmosphere, because the circulation of heat between the day and night side of the planet was not observed. Astronomers are currently conducting additional observations of the exoplanet TRAPPIST-1b, and now the team of scientists hope to obtain a complete phase curve showing the change in brightness throughout its orbit. Space Daily News. Like, share, and subscribe.